Hello friends, this is Durga from IT University. As part of CCA Spark and Hadoop Developer Certification, at this time we are talking about joining disparate datasets together using Spark. And we will be using Scala as programming language. You can scroll down and click on Spark Overview 1.2.1 documentation. And in that, there is a link for programming guide. You can go to the programming guide and scroll to the transformations, and you have a transformation called join, which can help you to join the two datasets. The only requirement is there should be a common key between the two datasets so that you can actually join the two datasets using this transformation called join. It's pretty straightforward. You just have to create RDD of two different datasets and join on the common key. We will see that as demonstration. And also you have other transformations under join. You have left outer join, right outer join, and full outer join. They are similar to any other database. So if you have two data sets, and if for a given key, if there is a data on one of the table, and if there is no data for that key on the other table, and if you want to get all the records, whether it is there on the other data set or not, then you will use outer join. If the table is on the left, from which you want to get the records whether there is any data on the other data set, then it is left outer join. And if the table is on the right, it is right outer join. And if you want to union both and get all the results, then it is full outer join. It is similar to join concepts in any of the databases. I will try to cover a video on outer joins as well, but for this video and the next few videos, we'll talk about join primarily. So let's log into the VM. So this is the VM. You can launch the MySQL database in this by getting into terminal. And here you can say MySQL minus u retail underscore DBA minus p, and the password is Cloudera. Use retail underscore DB and show tables. There are a bunch of tables here: orders, order items, categories, customers, products, which come out of the box when you actually provision this Cloudera Quick Start VM. And what we'll do is we will use orders and order items tables, and we will try to join these two tables and get the results after joining the two data sets. For that, let's define a problem statement. You can go to my GitHub account. So this is my GitHub account, D Gadraju, and this is my code repository. And in this code repository, there is a directory called Hadoop, PDW, Cloudera, Spark. So multiple directories which have a file called spark demo scala.txt. In this, you can scroll down for join disparate datasets together using Spark. And the problem statement is to get the revenue and number of orders from order items on daily basis. So the final result should have the date on which orders are placed, and for that day I need to get the revenue, and also I want to get the number of orders and I need number of orders from the order items table. Okay, and that too we should get for each day. So again we are now getting into the MySQL database again and see what is there in describe, what columns are there in describe. Orders table. Orders table have 4 columns: order ID, order date, order customer ID, and order status. So order date is the date on which orders are placed. So we want this information, and then we want the revenue also for that date. And if you see, orders table does not have the revenue. One order can have multiple order items, hence the table order items will have the revenue. So if you look at describe order items, hit enter, you can see it has order item ID, which is primary key, and order item order ID, which is foreign key to this order ID. and then it has order item, product ID, quantity, and a subtotal as well as product price. So subtotal is the one which actually customers paid for each item in the order. So what we have to do is, for a given date, we have to add all the order item subtotals after joining these two data sets on order ID and order item order ID. So first we need to join these two tables using Scala commands, and then we need to compute the total revenue for the day, for each day, and also total number of orders for each day. Okay, now you can exit from the MySQL database, start Spark shell, and as I have been mentioning throughout the videos, you have to use 1.2.1, and the VM does not come with 1.2.1, it comes with 1.3.0. For that you need to set up 1.2.1 Spark on your VM, and then you can launch using master. Sorry, I have to give the explicit path of the Spark shell of 1.2.1. So I have to do Spark 1.2.1 bin Hadoop 2.4 bin Spark shell master local. Here either you can use local to run in local mode, or you can use yarn. Yarn will take a long time, so I am using local, which will launch the Spark shell. Then first we need to read the data set from orders and order items. For that, I have already copied data from MySQL into HDFS, and the location is Hadoop fs minus ls user Cloudera scoop import, and if you hit enter, there are two directories in HDFS, one for each orders and order items, and we have to read data from these two directories in Spark, and then we have to join. So it's pretty simple to read. You can create an RDD variable like this, paste, and then you can use sc.text file and give the path user Cloudera scoop import orders, and hit enter. You can see orders RDD dot take 5 dot for each println, and hit enter. You can see the data is comma separated in HDFS. The first one is order ID, second one is order date, third one is order product ID, and fourth one is order status. And we want order date for the final result set, but to join with the order items, we need to get order ID as well, which we will do later. Similarly, if you want to create RDD for order items, you can say order items RDD, and then here you have to give the location, HDFS location for order items, which is under user Cloudera scoop import or import order items. Okay, hit enter. So now you can say order items RDD dot take 5 for each println, and hit enter. Now you can see that this is order item or ID, this is order item order ID. So we have to use this field to join with order items, sorry, orders table, and also we need to get this field order item subtotal to compute the revenue for each day. Okay, now we have to create the map function and create a new RDD to get order ID and order date from orders table, and we need to get order item order ID and order item subtotal for order items table. So the map function looks like this, and if you see, I am splitting the data using comma as delimiter, and the first field which is order ID will be the key, and I'm getting the entire record as the value, and we will use those records later to pull the order date from this. So first let us run this. I am passing orders RDD using map function, in which I am passing the record as a variable for the anonymous function or lambda function, and using that parameter I am splitting using the delimiter comma and fetching the first field from our result set, which will be the order ID, and that will become the key and record will become the value. You can hit enter, and now you can say orders passed RDD dot take of 5 for each println, and hit enter. You can see it has order ID, and then this is the complete record for each order ID. Okay. Similarly, the case you can do with order items also. In this case, I am using one as subscript for our array after delimiting with comma, and it will give us order item order ID. Okay, and paste it here, hit enter. You can say order items passed RDD dot take 5 for each println, and hit enter. Now you can see that this is the order item order ID, which is matching with this, and this is the record. Now using the key, which is the, as we are using the comma as delimiter for the data, and also Scala internally uses comma as delimiter between key and value in the tuple. This is little bit misleading, but the first entry before the first comma is key in this case, and the rest of the stuff is the value in each of the tuple, and this value is nothing but the record in the table. So now we can join these two. It uses the keys automatically and join the data set. Okay, so let us join. It's very simple. You just have to pass one RDD and then apply the join function on top of the other RDD. So order items RDD is one RDD, and on that I am applying the join function, passing the other RDD, which is orders passed RDD as parameter. So you can run this command. So these two are nothing but these RDDs: orders passed RDD, orders passed RDD, order items passed RDD, order items passed RDD. So you can apply either way. You can the join function will be available in both of the RDDs, and this is the new variable which we are creating to assign the join data set. So let's copy paste it. And hit enter. Okay, now we can say orders join order items dot take of 5 for each println, and hit enter. Now you can see that it is creating a key value tuple after joining the both data sets, and this is the key, which is nothing but order ID, and then this is the value for in each of the tuples. So this is key for this tuple, and this is the value for this tuple, which is nothing but a nested tuple. So it's another tuple which is the value in each of the tuple. And in this, again, comma is the delimiter, so it's a little bit confusing. But order items has 4 tables, 4 attributes or 4 columns. And if you look at the command which we have used, orders passed RDD is joined onto order items passed RDD. So this will be the right hand portion of this nested tuple. So these 4 fields will be part of is from orders past the RDD. So this is the record from orders data, and this rest of the fields is the record from order items data set. So each tuple have key and values, key being the joined key, which is nothing but order ID, and the value is a tuple which have order items RDD on the left side and orders RDD, order items record on the left side and orders record on the right side. Okay. Now we can process this one. Again, we can apply the map function and fetch whatever and fetch the tuple with whatever keys and values we want. In this case, the key is supposed to be order date, and the value is supposed to be order item subtotal. Order date is from orders table, order item subtotal is from order items table. And if you recollect the problem statement is to get the revenue and number of orders from order items on daily basis. And first I will get the revenue only. I will not get the number of orders, because orders repeat in the order items table. Hence we have to do it in a different manner. But first we will get the first portion of it. We will get the revenue on daily basis. Okay. So now you can copy paste up to here, then I will explain the rest of the logic which we will be implementing. This you will understand without much issues, and the complexity starts from here. So I need to create a parameter for our lambda function, and the parameter will be passed to this lambda function for each record. So this will be the line which will be passed to this, and for this, from this line I need to get order date, which is in the second item of the tuple. So I have to use t dot underscore 2, because I need to get order date, and order date is not in as part of the key. It's in the value of each of the tuples, and this value is represented by dot underscore 2. So the key the tuples can be accessed using underscore notation, and the arrays can be accessed through subscript notation using circular brackets. So as we have to use underscore notation to fetch the corresponding elements from the tuple, here by passing by using t dot underscore 2, it will read this portion for each of the record, and from there I have to get the orders record. Again, it's a tuple, so the second one will be the orders record. Okay, so this will be the orders record. Now on this I have to apply the split function. So all these attributes are of type string only. Hence I can apply the split function, and after applying a split function I can get order date by using subscript notation like this, with 1 as the parameter to fetch the date. And then I have to get order item subtotal, which is part of t dot underscore 2, which is this one, and then I have to apply split function. So this is 0, this is 1, this is 2, this is 3, this is 4. So to access this, what I have to do, t dot underscore 2 dot underscore 1 to get the order items record, on which I can apply the split function, and I have to use subscript 4 to get the order item subtotal, and hit enter. Okay. Now the new RDD revenue per order per day is created. Okay, you can say take of 5 dot for each println and hit enter. Now you can see that for each day, for each order, even though it is not we are not fetching the order ID, which is not required to compute the revenue per day, but each entry is for each order for each day. That's why I named the RDD as revenue per order per day. And now after joining the dataset, we got the date and order item subtotal together from two different datasets, which we can use to compute the total later, and we will see that in a while. So that being said, one more thing what we have to do is, when we apply the map function here, we have to apply the to float as well, so that when we actually get order date and order revenue, it is the order revenue is actually represented as float. Otherwise, as the record itself is string, after applying the split function, it will create the array of the strings, so it will be represented as string and it can cause issues downstream. So for now, we will also apply the to float function on this, and you can copy and paste it here and hit enter, and now you can actually validate revenue. You can see that now the RDD is actually of type tuple string with attributes of type string and float. Earlier, if you don't apply the to float function as earlier, the tuples will be of type string and string. So you have to typecast so that we can add later to generate the revenue for each day. Okay, so that being said, we have done one join and get the order date and revenue for each order for each day. You can also again validate after applying the to float function also, revenue per order per day dot collect or take of 5 for each println, and hit enter. So we have covered joins in detail, and we have covered first part of our problem statement, which is to get the revenue for each day for each order. But we haven't finished the complete problem statement. The actual problem statement is to get the revenue for each day. So we need to aggregate on each day basis. At this time, we only join the dataset and get revenue for each order for each day. And the second portion is to get the number of orders from order items on daily basis, which we will see now. And then we will do the final join to co-locate the revenue and number of orders from order items side by side. So to get the orders per day, we need to order items table. I will explain you why. You can go to MySQL and you can see that the number of orders in orders table is 68,883, whereas the number of orders in order items table after applying distinct is only 57,431. The reason is not all orders might have entries in order items table. If there is an entry in order items table, there can be multiple entries also. That's why we need to apply distinct, and also we need to get the results from order items table only, because that's the one which actually generated the revenue. So if you want to compute the average revenue for the successful orders, you have to get both the revenue as well as the number of orders from the order items table itself. That's why the problem statement is defined like this: to get the revenue and the number of orders from order items on daily basis. So to get the number of orders on daily basis, we have to use the same joined RDD, which is this one, and apply map function, and apply the same logic of _2 split of 1 to get the order date. And then I am actually concatenating order ID to the order date by using plus. So here, instead of creating the tuples, I am just creating a single element RDD in which our date and the order ID is actually concatenated, and let's see what will happen. So I am applying this logic, without assigning to RDD, pasting it in Spark shell, and then you can see collect for each println and hit enter. I should have done take of 5. Okay, anyway, you can see that for a given date, for a given order ID, there can be multiple entries. That is obvious from this one, where we have the same order ID of 53,179 on the same date of 2014 June 25th. Similarly is the case with this. We have 3 entries for order ID 58,423 on date 2013 August 20. So to get the distinct orders for each day, we have to apply the distinct function. That's why the distinct function is here, and then I am assigning to RDD called orders per day. Okay, paste it, and now if I say orders per day, take off 5 for each println and hit enter. Now you can see that those orders are not repeated. Okay, so now we have the revenue per order per day and orders per day, but we have to again out of this one we need to create the tuples of order date and 1, so that we can add all those ones to get the number of orders per day. So for that we need to apply the map function again on this RDD, so which is this, paste it here. I don't want order ID here, I need number 1 after the date, so that I can add those ones to get the number of orders per day. So again I am applying the split function because in the previous results it's a single valued tuple. There are no 2 values. Comma is misleading. It is the delimiter here, and it is only 1 attribute. There are no 2 attributes. If it is a tuple, it will be in the circular brackets. Here it is not in the circular bracket, which means it's a single string. It's not a tuple. Hence I have to apply the split function on it and get the first string, which is date, and the value I am assigning 1, and now this orders per day passed RDD will have a tuple of order date and 1 for each order, and hit enter, and now I can say orders per day passed RDD dot take of 5 for each println and hit enter. You can see the number 1 is assigned for each day for each order, and if you actually do sort by key and then take 100 and then for each println and hit enter, you can see that for each day there are multiple entries because there can be multiple orders, and we have applied already distinct on that. So for each distinct order ID we are assigning 1, and using this result set we can actually compute number of orders. It's pretty straightforward. We just need to use a function called reduce by key, and it is considered to be a transformation with under aggregation. You will understand the complete logic of reduce by key when we actually discuss about aggregations. So for now you can just copy this and paste it here, and now you can do orders per day dot take of 100 for each println to review the results after applying the aggregate function reduce by key on the total orders per day. Now you can see that for each date we are getting the number of orders, distinct orders from order items dataset. And also the revenue per order per day gave you the revenue for each order per day, but to get the revenue per day we just need to add all the revenues for each order from the result set. So again you can use the reduce by key and the total one and total two, total one is the accumulator and total two is the value, which is nothing but per date per order revenue, and we are adding those, reducing by key, which will get us revenue for each day. So you can just copy it, paste it here. Make sure that you run the toFloat function on the revenue, otherwise it will be concatenating as a string. It's very important to typecast, and hit enter. Now you can run this command and paste it here and hit enter, and you can see that you are getting the revenue for each day. Okay, and then you can join these two data sets the same way as we have joined earlier, and paste it here and hit enter. Now the total orders per day has number of orders for each day, and the total revenue per day has total revenue for each day, and the date is the key in both the cases. So based on key we are joining the two data sets, and now you can run this final join rdd dot collect dot for each println and hit enter, and you can see that for each date you got the order items and the revenue, and using this data set you can calculate the average revenue just by dividing the revenue for each day with number of orders for each day, which we will see again when we actually talk about aggregations. That being said, that's it about joining the two datasets. We have used simple join and joined the orders and order items and computed the total revenue as well as total number of orders for each day. That being said, we will discuss further on joins using Hive context as well as running SQL queries in Scala context itself. So you can actually run SQL queries in either in Hive context or Scala SQL context. So we will try to run in both the contexts and see how we can actually join the data sets using SQL queries to make your life easier if you are already familiar with SQL at the time of certification. That being said, I hope you are enjoying the content on the channel. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to discuss further on the certifications, please join my LinkedIn group called ITversity minus Hadoop certifications. If you have any technical questions, go to the Stack Overflow and raise your questions with the appropriate tags. And if you have not subscribed to the channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.